What's in the News space specials are funded by NASA through the Pennsylvania Space Grant Consortium.
Every one of us is affected by the weather every day. We dress for it, we make our plans by it, we travel and work according to weather forecasts, predictions about the kind of weather we're going to have.
We know much more about the weather today than ever before because of weather satellites. Satellite technology has allowed us to become better at observing and predicting weather. Hi, I'm Troy Thompson.
And I'm Joy Mattman, and this is Eyes in the Sky, Weather Satellites.
Just take a look at the numerous highs and lows which surround Pennsylvania.
Before the age of satellites, weather forecasting was mostly just educated guesswork.
Afternoon and evening thunder showers.
And we'll get carried up to the northeast here, and it'll probably hit somewhere, I would guess, up around Tallahassee, although...
Today, thanks to satellite technology, the weather can be predicted with greater accuracy.
Today, thanks to satellite technology, the weather can be predicted with greater accuracy.
Because this storm is, as Paul Knight said, a doozy and has the potential to produce 1 to 2 feet of snow across much of the state. That snow blown and drifted about by 30 to 50 and even higher mile-per-hour winds.
Some satellites contain special cameras and sensors that record information about the Earth's atmosphere, such as the location of clouds and storm systems and their movement from one place to another.
One group of weather satellites is orbiting the Earth from north to south. They're called polar orbiters because their paths take them over the north and south poles. 2 polar orbiters move in opposite directions, crossing the equator twice a day. They're about 830 kilometers or 500 miles away from Earth. Their main job is to record air temperatures above the ocean at different levels. Weather stations can't easily be built on water, but polar orbiting satellites act as the next best thing, measuring air temperatures, humidity, and wind speed.
The other group of weather satellites orbits the Earth above the equator. These satellites are geostationary. Geo means Earth, and stationary means in the same place. These satellites are geostationary. Geo means Earth, and stationary means in the same place. Geostationary weather satellites orbit the Earth in the same direction the Earth rotates on its axis. Their orbiting speed matches the Earth's rotation exactly, so the satellite seems to remain stationed over the same spot on the Earth. Geostationary satellites orbit 36,000 kilometers or 22,000 miles above the surface of the Earth. Because they're so far out in space, they can see 1/3 of the Earth at a time. They can observe cloud and weather patterns as they develop and move from place to place across thousands of miles. Geostationary orbiters are used to study and track tornadoes. They tell weather forecasters when conditions are right for a tornado to develop, although we still haven't learned to predict when and where one will touch down. Geostationary and polar orbiters work together to provide a global picture of developing weather patterns.
Satellite information isn't of much use unless people can gather and use the data and pictures satellites collect. This antenna dish is a link between an orbiting satellite and a receiving station on Earth. Here's how the information is gathered. Orbiting weather satellites send raw data and images to a satellite dish in Wallops Island, Virginia. There, a computer converts the data into useful pictures. These pictures are transmitted up to a communications satellite, which then sends them back to receiving stations on Earth. Orbiting weather satellites send raw data and images to a satellite dish in Wallops Island, Virginia. There, a computer converts the data into useful pictures. These pictures are transmitted up to a communications satellite, which then sends them back to receiving stations on Earth. Anyone with an antenna dish in the satellite's path can receive these weather pictures. Before the invention of weather satellites, how did we think about the weather? Before we had satellite pictures, theories about the weather could not be easily checked, if at all.
In the 1700s, Benjamin Franklin speculated that weather systems, like clouds, move from place to place. This was an uncommon theory for its time. Benjamin Franklin speculated that weather systems, like clouds, move from place to place. This was an uncommon theory for its time. Most people believed storms were born and died right where they occurred. Some people even thought that weather was caused or influenced by magical or supernatural forces. With limited communications, people didn't know the nature of weather more than a few kilometers away. With the invention of the telegraph, telephone, and radio, weather forecasters could gather information across larger distances. Then came radio signs, an invention of the 1930s. Radio signs look like long teardrop balloons. Radio signs look like long teardrop balloons. They measure temperature, pressure, and moisture at upper altitudes when released into the sky, and they're still used today. Airplanes gather weather information too, but a really big breakthrough in weather forecasting came in April 1960 when NASA launched America's first weather satellite. PIROS-1 took pictures of more than 2/3 of the Earth's surface. For the first time, meteorologists could see the global sweep of weather and the symphony of atmospheric motion. Today's satellite pictures have become much clearer and reliable. It's also common practice for shuttle astronauts to take pictures of the weather. Paul Knight enjoys his job so much that he is not only a meteorologist, but he teaches meteorology too, and co-hosts a daily television show on the weather. Without the atmosphere, or air that surrounds the Earth, there would be no weather. Our atmosphere is a moving ocean of air. The air moves because of differences in the way things get heated. Some things get heated more than others. During the day, the air warms. At night, the air cools off. This constant heating and cooling of air and of water vapor and dust in the air gets air moving from one place to another, forming clouds, fog, humidity, storms, all kinds of weather.
Meteorologists describe Earth's atmosphere as having several layers, based on the temperature and heaviness or density of the air in each layer. The layer closest to the Earth is called the troposphere. It starts at the Earth's surface and continues outward for about 16 kilometers or 10 miles. Tropo means turning or changing. This is the layer in which weather occurs.
Scientists study information about weather on other planets too, with the help of interplanetary probes. Learning about the weather on other planets can help us better understand Earth's weather. Learning about the weather on other planets can help us better understand Earth's weather. The moon has no atmosphere, so it has no weather. But the planets Jupiter, Venus, and Mars do have atmospheres, and scientists do study their weather. They can analyze the giant dust storms that occur on Mars, carrying fine dust around the entire planet and changing the planet's temperature. Such studies may help scientists find out more about the effects of dust in Earth's atmosphere. Meteorologists can examine the swirls of clouds around Venus and Jupiter and apply some of what they see to understanding Earth's cloud cover.
Satellites do more than help us forecast the weather. They can survey crops, forests, and plant growth, and locate dying trees by measuring the intensity of green light reflected from trees and other plants on the ground. Satellites can detect volcanic eruptions and warn approaching airplanes of the volcano's dust storm. Satellites can measure damage and the effects of volcanic eruptions years later. They can locate schools of salmon and tuna too by sensing water temperature. Satellites allow us to learn much about our Earth and environment. They can help us identify global problems such as population overgrowth, lack of food, too much energy consumption, and environmental pollution.
They can help us identify global problems such as population overgrowth, lack of food, too much energy consumption, and environmental pollution.
Maybe you'll help us understand and solve some of these environmental problems using information collected by satellites.
What role will you play?